Do you have any questions? Okay, so now we talked a lot about C and C++ and compilers. You won't be needing any of that for this presentation. So we'll be talking about Python, and we'll be talking specifically about the interactive Python shell. Before I begin, I would just like to check how many of you are familiar with Python and how many of you are comfortable with Python. Can you just raise your hand? Okay. So not that many people. But you're in luck because this presentation is kind of beginner-oriented and you'll be able to take away a lot from this one. Before I begin, I was already introduced, but I'll introduce myself once again. My name is Faris Likic, and I work at Pro Safety in Sarajevo. And we have been using this exact tool for quite some time, and I would like to share some outtakes from this project with you. So, the first topic we'll go over is basically what is Python and what is IPython, or the interactive Python. So, at the very beginning, Python is a very popular language. Even though if you haven't used it, you must have heard of Python. And coming back to the previous speaker, it's not a compiled language, it's an interpreted language. And what this means is you install a program called the Python interpreter, and it goes through your code line by line, and it is able to execute Python code line by line. This code execution can happen in two distinct modes. The first one is the script mode, and the second one, which is a little more interesting to us today, is the interactive mode or the REPL. And we'll get back to the REPL a little bit later. Python also supports packages and modules, and this is also highlighted because this is very important for our topic today. And there's a long-running joke on the internet. This is how you usually solve problems in Python. If you have a problem, you don't solve it yourself, you import some kind of a solver, and that's how you get your solution. It's not always like this, but sometimes that's exactly how it works. So the Python REPL is, you can think of it as an interactive way to talk to your computer. It's basically a live chat between you and your computer, and the language you're using is Python. And the whole process is known as a REPL because it goes through 4 steps or 4 stages under the hood. The first one being it reads your input. The second one, it evaluates your Python code. Then it generates some kind of an output, and then it loops back to the very beginning. And that's how you get this back and forth between you and your computer using Python. So why are we talking about IPython now? What is it even? Python has something that's, it's a built-in Python shell or Python interpreter, which you can use. And the IPython is basically the same thing, but on steroids. So it has a lot of features, and it makes your life a whole lot easier. It provides a more user-friendly experience. First of all, it does syntax highlighting. If you've been using development environments or coding editors, you've seen this and you've used this, you're used to it, and now when you go back to typing code without it being all these nice fancy colors, you kind of don't like it. So this lets you keep that. It also allows for auto-completion for variables, functions, and modules, just like in the IDEs and the editors. It has an integrated help system, which is very useful. We'll see how this is used. And it also has something that's called magic commands. On the left side, we have the standard Python shell, and we just have a string Python assigned to a variable that's called outString, which is basically an object in Python. And Python also uses the dot for calling different methods of the object. If you do not know what's implemented for the string, you're going to have a difficult time with this. If you're used to working in Python, this is going to be okay. But on the left side, we have the same setup. But if I type the dot, I get a list of all the possible methods I can call on this particular string instance, which is really useful. And as you can see, it also has this syntax highlighting in the string as well. It also has a built-in help system, which means if you are not sure how to work with some kind of an object, you can basically type out the name of the object and add a question mark behind it, and you get all the details about this object. And there's also something that's called a docstring. This is more or less just a description of a Python function, module, you name it. And whatever you type in here, it's going to be displayed when you invoke this help command. Okay, so let's take a look at these magic commands next. The first one is called timeIt. The way you invoke them is you type this %sign and the name of the command. And for example, here we have a command that basically tells us how long it took to execute this particular piece of code here. The second one, for example, is run. This command allows us to run some kind of a Python script. So this can be very useful if you're working with some kind of a machine, and let's say you have a Python file that generates some kind of a report. You can basically invoke it directly through your interactive session. The next one is debug. You can basically use an interactive debugger on the spot. If something went wrong, you can see what went wrong, and you can do all kinds of stuff that you can do with a normal debugger. PVD, it tells you your current working directory. Recall is another one. As you can see, all of these inputs in the interactive Python shell have this number assigned to them. This is the, let's say, cell which they belong to. And let's say I made a mistake in the cell number 3. Instead of adding these two numbers together, I wanted to multiply them. I can just say recall 3, and it's going to give me the exact input I gave. And then I can correct it and do whatever I want with it. Of course, this is a simple example, but imagine you have a big formula that you need, I don't know, to change some kind of a minus somewhere. It's going to be very useful. Another one is matplotlib. If we want to output some kind of data, we can use this matplotlib command, and it's going to generate something like this. In this particular example, but it could be anything that you implemented. And there's many more, and I'll stop right here, but you can of course check them out yourself, and I'm pretty sure that there's many of these commands that you can find particularly useful for your project. Okay, how to install this interactive Python? Well, that's simple because it's a standard package, just like everything in Python is. And it can be installed through all the usual channels. So you can install it through pip, running the pip install command, or through conda, or through uv. And once you've installed it, you can basically open a terminal session, type IPython, and this is the output you're greeted with. So we've now seen how you can use the interactive Python, but this is not where it shines. Where it actually shines is it allows you to generate some kind of a context and then use its embed method. This embed method basically generates like an interactive sandbox or a playground, giving you access to all of the objects that you have previously defined. We'll see how that works in a minute. But it basically allows us to generate some kind of a setup, and we do not have to repeat it every time. Rather, we type out a script that does that, and we execute this embed command, and then we have all of that setup performed for us, and we get to work with Python interactively at that point. This is how it works. So first things first, we have to generate some kind of a context. This context could be anything, but let's go over some of these things we prepared for you here. So first of all, you could connect to some kind of a device. That device could be some kind of a remote device, or it could be a simulator or some kind of an emulator, you name it. Then you could parse arguments. For example, you need some kind of a mode that you're going to be working it in, either software or hardware or you name it. You can specify a target machine. If you have multiple machines that you're usually connecting to, you can specify which one you want to connect to, or whichever parameter you're passing in here as a value. You could also load some data, maybe some kind of configuration or some previous measurements that you have performed. When you've done that, you set everything up, and then you can invoke the embed method from the interactive Python shell, and it's going to take into consideration everything you prepared for it, and it's going to give you an interactive environment to play with. Okay, let's see how to integrate IPython. At the very beginning, it's important to note that IPython is more or less just an interface. You have to put in a lot of work in the background to get it to run, but it offers you many, many features that you can find very useful, I'm sure. Okay, so your embedded device has to have some kind of a way to communicate with the IPython shell. And I've listed some of them out here. It has to have support for some kind of an RPC-like framework. It has to have UART connection or maybe some other interface. Or you need to have a proxy or host device. And like I said earlier, you have to put in some work first. How the system usually works is the following. We'll take a look at a general concept. First of all, you have the IPython shell, and this can be used for controlling your system, running some kind of diagnostics, executing tests, generating reports. Then you have some kind of an interface. And this interface could be a topic of its own, and maybe it is going to be a topic next year at this gathering. But basically what it does, it takes a message from the IPython shell and translates it and sends it over to your device, and the same works vice versa. And how you would implement this is very project specific, hardware specific. You might have some kind of requirements that you need to meet. So like I said, it's a topic of its own, but we want to list it out here as well, just so you have the full picture. And then at the very end, you have the embedded device. And we do not need to talk about that because you all work with them. Like I said, the focus of the presentation is the shell. And you can think of it as a tool for, let's say, field technicians. They need to know what they need to execute and how it works. And they execute those commands. They generate some kind of a report, or maybe they do some maintenance work on it. They do not need to know how every nook and cranny is implemented in the system. They just need to know what they need to interface with. And it has a very customizable user experience because you are the one designing all of it. Okay, I'll list out some possible ways of integrating this. If you're looking at the slide and you have no idea what this means, then that just means you haven't worked with many systems yet, and you haven't had many projects yet. But if you have worked quite a bit in the field, you will recognize some of your projects here, and you would know where you would need to integrate this. Like I said, it takes a lot of work, but it's very rewarding at the very end. And what are some use cases? Well, first of all, it allows for increased or easier debugging. So it offers us a lot of debugging features. It just basically has a higher degree of flexibility with integration tests, if you need to do some kind of integration tests. It has really strong reporting capabilities, which you can fine-tune to your liking and your needs. Of course, if you need to generate a PNG of how your system boots up, you can do that. If you need to generate a 200 side PDF with all the little details, you can also do that. You're the one designing it. This is also really good because it lets you demo features that you are not fully committed to. You can try out smaller things. You just implement what you want to work with, and you can try playing around with it to see if you like it, if it's something that you want to go forward with. There's also always something to show. So it wouldn't take you, like, I don't know, 3 months to develop a feature. It would take you only 15 days to have some kind of a proof of concept. And if you like it, then you move forward with it. If not, then you scratch it out. And the last one, this is more or less just a user interface, but it's a solid one. You get to work through the terminal. But this can also be a good starting point for an HMI or a GUI, because if you just develop a GUI, it can call these functions and execute those commands when you click on a button. Okay, now we have a short example. This is some kind of a system. You have a device that's connecting to a embedded device. You have a sensor, an actuator, some kind of system you're controlling, and then whatever else you want to have. So we would basically execute or call Python and then execute this Python file, embedded device interface py, and then we would pass it a few command line arguments. This is exactly the context we were talking about earlier. And how some kind of a main function would be implemented. This is just a very bare bones example, but it kind of gives you an idea of how this actually works. At the very top, we have some packages imported, and then in the main part, we parse our arguments. We generate an object called a com object, which is basically just an instance of a com handler, and then we connect to some kind of a device and we configure this device. Take note that everything that's on the left side, so arguments, com object, com dev, embedded dev, all of these things are available to us now when we execute the embed. This is what I was talking about earlier. This is the context we're generating. You can have anything here. You can have a specific module for generating reports, for example, running integration tests, connecting to a machine, restarting the machine, you name it. And when we execute embed, we get all of these objects available to us. When that happens, we'll get some kind of an output, and this is the screen we're working in right now. We have this input cell, and we can start playing around. We have this open sandbox right now. So if I say embedded device and execute the LED on it, in the background, I would, of course, implement some kind of a function that would turn this LED on. This is just a very simple example. This could be anything. It could make an airplane fly if you want to implement it that way. Another example here is we're generating some kind of a graph. We connect it to the device, ran some measurements, and now we want to generate some kind of a report. Well, we can do that when we implement the function check and graph IO. And when we implement it, it's going to generate some kind of a PNG. In this example, it could be a PDF or anything that you would like. And then at the very end, I would just like to sum everything up once again. First of all, this tool is very flexible, it's customizable, and it's interactive. It's easy to use, and it's not only limited to developers. Like I said, if we generate or create a system that's user-friendly, someone who just does maintenance work on our machine can just connect to the machine through a terminal, because he's going to have a function called connect to green device, whatever, and he can start working with it. This also, of course, boosts productivity and streamlines testing. We have to consider the time we put into creating everything, but when we have everything, it's really easy to implement some kind of unit tests, integration tests that we can run through it. I was already talking about this quite a bit, but it generates reports and makes this process of system reporting and overviews a whole lot easier to obtain. We also mentioned this. It lets you quickly test a feature before building it. And the most important one is you get to feel like a hacker by working through a terminal, connecting to a device, and doing all sorts of things with it. And yeah, that would be everything. I hope this presentation was somewhat useful to you, and that you at least now know what the IPython is, and you have to check it out yourself to see all of its features. Thank you.
Thank you, Faris, for the great presentation. And I think you know the drill. Please raise your hand and ask a question.
Everybody's tired, I think.
There must be at least one question. There is a question.
Yep.
Yeah.
Hey, thank you. So my question is related to security, actually. So is this shipped on device? Or because the last sentence that you said about hackers, so people will actually do it, like other people, they will actually try to play with your device. I know a lot of those people. So what are the, like, is there any kind of protection for that?
So if you're looking for some kind of built-in protection straight out of the box, then no. But of course you can make a workaround yourself. So if you want some kind of protection measure implemented into your system, you would have to develop it yourself, just like you would have to develop the way the messages are transmitted, they're translated, and they're handled. So it's still up to you, and there's no like straight out of the box magic feature that makes this super secure. No.
Thank you. Because a lot of people can actually just like connect, right, and reverse engineer everything that you are actually doing and mess with your device. Right.
That's true, of course, but you also have to consider what kind of environment you're going to use this in. If you're using it in a closed-off environment, let's say for testing, you're building a machine that's only meant to test something else. It's going to be within your network. It's not going to be online and whatnot. And then you don't have this issue at all. But if you are working with some kind of a device that's on the network and whatnot, then you would have to think about this issue as well. So yeah, but you would have to work on it by yourself and figure out a way how to make it secure.